and these laws also we were discussing in the last class. Okay, today I'll be taking, just a moment. See this question number 1, you will be able to do all by yourself. Okay, number 1, just you have to find the union of each of the pair. X is there, Y is there, you have to find the union. A is there, B is there, you have to find the union. Then A is there, B is there, this is written in set builder form and you have to find the union over here. Similarly, the next one, A and B is there, just write it in roster form, you will be able to write the answer directly, that what will be the union. Then this number 5, 1 2 3 is there, 5 is there, union means everything, so it will just contain 1 2 3. Okay, the union of A and B. Now the next one, I want to take today Venn diagram. Okay, that's why I am just leaving these parts for you. Let me check the second one, the third one. Let A is this one, B is this one, A contained in B. What is the A union B? Yeah, you'll be able to do this. You'll be able to do this as well. A, B, C, D is given. Then A union B. Yeah, these all you'll be able to do by yourself. Here also, okay, number 9 till 8, you will be able to do all the question. See, the set of pair sets are disjoint. Disjoint means, see, let's decode this language. Disjoint means not joint, right? Two sets
Yes,
which are not joined with each other, that's called disjoint. Okay, and here we will say disjoint means if there is no common element. Not joint, that means there is no common element at all. If you will try finding the intersection, you will end up getting the intersection as a 5. That's called disjoint set. Disjoint. Okay, so you have to check over here that which two are disjoint. Here, for I'm talking about number 8. Okay, if there is no common element, those sets are called disjoint set. Anytime if you will forget the disjoint for just concept, just focus on the name, disjoint, no common element. Okay, so number 8, you can see 1 2 3 4, one of the set is given, another set X is set of natural numbers such that X is lying in between 4 and 6. So you can check, you can first write this set builder form in roster form. You will be having all the numbers in between 4 and 6, touching 4, touching 6. Okay, so 4 will be there, 5 will be there, 6 will be there. Now you can see, is there any common element in these two sets? So yeah, of course, I can see 4 is here and 4 is here. So these two sets are not disjoint. It's not disjoint. Are you getting it?
yes, ma'am.
Similarly, you have to check the next one and similarly the next one. Disjoint means there should be no common element. If that is the case, then yes, the two given sets are disjoint sets. Now, complement of a set from a universal set, if you will, if we are finding the, suppose there is universal set. Okay, the universal set is containing like 1 2 3 till 10. Okay, and there is a set A containing an element 1 1 2 just. Then if you have to find the complement of A, complement of A, that means A dash. If you have to find complement of A, that means A dash, if we have to find, that will be this universal set minus A. That means the element which is there in A, that we cannot take. Complement of A means not A, not A. So we cannot take element of A. So what we will take, the final answer will contain what? Everything from the universal set, but not the element of A. Getting it? So we will be having, see, we will be having 3, we will be having 4, we will be having 5, 6, 7, 8, 9, 10, but not 1 and 2, because A is containing 1 and 2. So from the universal set, I am taking everything except whatever there is in A, because A dash or A complement means not A. We don't want to take A. That means just exclude A from the universal set and then write the answer. Getting it?
Yes, ma'am.
Okay, so that's the condition for this one. I'll introduce today Venn diagram also. Quickly, I'm checking if any question is there which we can do. Yeah, question number 3. Okay, taking the set of natural number as universal set. Here, our universal set is the set of natural number. Our universal set over here is the set of natural number, and we have to write the complement of each of the following. Complement means, okay, the first set you can see written over here, we have to subtract it from the universal set. So if the first one in set builder form, it says that set of all x such that x is an even natural number. Even natural number, your universal set is the set of natural number. All natural numbers are there. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, till infinity. All the natural numbers are there. That's your universal set. And the given set, the first part, A, I'm just naming it, that let's call it a set A. Then the given set A is a set of even natural number. That means that A will contain 2, that A will contain 4, that A will contain 6, that A will contain 8, that A will contain 10, like that. And if you have to find the complement, read the instruction. Taking the set of natural number as universal set, write down the complement of the following set. You have to write the complement of each given set. Complement. Okay, that means you will be subtracting, you minus it, or you will say that you want to take everything, but the element which is there in A, not those elements. So these even number we don't want to take. So what will be remaining? Can I say that our answer, okay, A complement will be the set of all x such that x is an x is a odd number, set of all odd natural number. Can I say that?
Yes, ma'am.
The way question is presented in front of us, same way we are writing the answer. Okay, U and A, whatever I have written over there, that is just for your understanding. But directly we can write that complement of the given set will be set of all x such that x is a set of odd natural number. If you will subtract even natural number from the collection of natural number, you will be getting odd natural number. Let's see the next one. Set of odd natural number, complement of this one will be even natural number. You already know. Number 3, part 3 over here. Set of all x such that x is a positive multiple of 3. Positive multiple of 3. Multiple of 3 means 3, 2 times 6, 3, 3 times 9, 3, 4 times 12. Actually, these are the multiple. 3, 6, 9, 12, 15, 18. These are the multiple of 3. Okay. Here you have to take the complement of this set. A set containing these elements. You can see the table of 3. And table doesn't mean, multiple doesn't mean that it will end at, okay, 3, 10 times 30. No, it will not end over there. It will keep on going and keep on going. So we will say that complement of this part 3 will be, complement will be, the given set's complement will be set of all x such that x is a positive, x is, directly we can write x is all those number which is not multiple of 3. Okay, x should not be multiple of 3. Got it?
Yes, ma'am.
Okay, from the set of natural number, we are thinking how to write the remaining number. 3, 6, 9, 12, 15 here we are getting. But all those remaining number, that is 1, 2, 4, 5, okay, 8. How to write those number? We are not getting any pattern over there properly. So we are saying that complement will be, okay, not multiple of 3. We are just excluding the multiple of 3. That's the complement of the given set. Number 4, x is a prime number. Prime number means 2, prime number means 3, then prime number 5, then another prime number 7. You want to just exclude these numbers from the set of natural number. So you are thinking what to write, what will be the better terminology. I am thinking that can I write composite number? All those number which will be remaining will be composite. But the moment I am going to write composite, one thing is clicking in my mind, that if you will exclude, see, natural number, 1 will be there, 2 will be there, 3 will be there, all number will be there. Prime number, 2 will be there, 3 will be there, okay, 5 will be there. This is prime number. You are just excluding these prime numbers from the set of natural number. So all those composite number will be remaining, but 1 will also be remaining, right? And in class 10,
Yes, ma'am.
the first day, your first class, you got to know that what is prime number, what is composite number, and one is neither prime nor composite, right?
Yes.
Okay. So the moment we will write that x is a set of all composite number, x is, okay, all composite number. That means we are leaving one. Okay. So if you are writing this way, there are two ways to write it. Either write that x should not be prime number. Okay. X, set of all x such that x is not prime number. Okay, just include the terminology. Yeah, no need to include anything else. It should not be prime number. Either you write it this way, or you are writing composite number, then write specifically that, okay, and x can be any composite number, I mean, or x can be 1. Getting it?
Yes.
Number 4, Manvi, are you getting it?
Yes, ma'am.
Okay, so this is how we'll be writing. If we will find the complement of a set, which is a set of all prime number, we will have a set which is a set of composite number, but including one. Including one. So we will specifically say that x can also be 1, or x can also be 1. Like this. Okay, number 6. X is a set of all perfect square number. You have to write the complement of this set like this only, in set builder form only. So you will write set of all x such that x is not perfect square number. Okay, all those remaining number which will not be perfect square number, we will be left with those numbers. So we can say that x is not perfect square number. Clear?
Yes.
Similarly for perfect cube, this x plus 5 is equals to 8. If we will solve it, this set will contain x value, okay, which will satisfy this equation. That means you solve this equation, x equals to 8 minus 5, 6, 7, 8. So your set will contain only 3. So how to define this one? So we will say that from universal set, we are going to remove this 3. Okay, we will say set of all x such that x is any natural number, and and means very important. This should, okay, get followed, and x should not be 3. Clear?
Yes, ma'am.
Similarly for the next one, okay, this 11. Let me check the next one. Just a moment. Yes, Nabila and Manvi. Yeah, let's continue with the discussion. So we were
Yes,
doing
ma'am.
the complement of each and every set. We are done till number 7, right? Right?
Yes, ma'am.
Okay. Next one is also like that. I mean number 7, number 8, number 9. Okay. Number 9 is also same. Number 10, you can see x must be bigger than or equals to 7. Okay, x must be bigger than or equals to 7. That means x can be 7, x can be 8, x can be 9, x can be 10, x can be 11. This is the set that is written in number 10, and you need to find the complement. That means you need to exclude this. Okay, That means you will define the complement of this particular set for 10. Okay, suppose you are saying this is x, so x complement will be all those natural number which is smaller than 7, just smaller than x is smaller than 7. Getting it?
Yes, ma'am.
Next one we are having here, set of all. Okay, x belongs to all natural number 2x plus 1. You can find the x value and you can check. Okay, your x is lying in which range. From here you are going to get 2x plus 1 is bigger than 10. That means 2x is bigger than 9. That means x is bigger than 9 by 2. 9 by 2. That means 4.5. You are talking about all natural number which is bigger than 4.5. So 5, 6, 7, 8, 9, 10, all till infinity. Okay, so you can take your x is bigger than 4.5. That means actually your set is containing all numbers from 5, right? All natural numbers from 5, right?
Yes.
So you will say that set of all x such that x is a x is any natural number and less than 5. Got it?
Yes, ma'am.
Okay. Now Venn diagram. Let me give you quickly the concept of Venn diagram. Just a moment. Okay. So we are done. Okay. Venn diagram I'll be explaining. I'm sharing another screen. And yeah, today only we will be able to start the next chapter, that is sequence and series. Manvi, that particular question where you are having where like there is a set A, set B, set C is there, and then like A union B, B union C, C union A, these things are given over there. Do you know those type of questions, Manvi? Like, I mean, I'm showing with the help of Venn diagram, and tell me whether this type of questions are clear to you or not. Uh, if it is clear, then I'll not take. I will just move to the sequence and series. Yes,
Vidhi?
just a moment. Can you see the screen?
Yes, ma'am. Ma'am, will you take relations?
What?
Will you take relations?
Yeah, relations we are having. Do you want like to start relations first?
No, I'm just asking if you're going to take it.
Yeah, yeah. Relations chapter will I'll take. Okay. I I am saying that yes, Manvi, for you, have you seen this type of question where three three circles you are having and the common in between A and B is given, then common in between B and C is given, then common in between C and A is given, then all three common that too is given. Have you done such question?
I've seen such questions, but I've not done any.
Uh, can you please repeat?
I've seen such questions, but like I haven't properly practiced any. It came for my exam though.
Yeah, so I will be taking after discussing the Venn diagram, we'll be taking it over here. Yes, Nabila, from your syllabus, it is excluded, right? The word problems.
Yes, ma'am.
Okay, this time it's not there. No worries. Let me introduce the Venn diagram. So we are having, if we are talking about A union B, we will be representing it. First, we represent Venn diagram by using a rectangular bracket like this, where this rectangle will show you the universal set. Okay, the rectangle shows the universal set. Here we'll be having A, here we'll be having B. This common part represent the common element in A and B. So suppose our A is 1, 2, 3, 4, 5, and our B is, let's say, 3, 4, 7, 8. Then 3, we can see 3 and 4, these two are the common element. We will be writing it over here. And the remaining all from A, we will be writing that 1 is there in A, 2 is there in A, 3 and 4 already, okay, included in A as well as in B, and 5 is there in A. Getting it? Manvi and Nabila, both of you. Okay, then 3, 4, 7, 8, 3 and 4 will write like this, and 7, 8 like this. Okay. Similarly, if intersection will be there, then we will only write the common element. That means this two set, and only we will write the common element over here like this. Okay. Then if A minus B is there, that means not B, element of, okay, A, but it should not be in B. Okay, we don't want B element. So 1, 2, 3, 4, 5, that is the element of A. But 3 and 4 is there in B. So we will exclude that. Only 1, 2, 5. Right?
Yes, ma'am.
Okay, so A minus B, if we have to represent by using the Venn diagram. So the same way we can represent two circles like this, only always we draw. But if we have to shade and represent A minus B, so we will say only this part A. Okay, we don't want the common element and we don't want B. This is just the shaded part is representing A minus B. Are you getting it? You can understand here 1 to 5 will be sitting already. 1 will be there, 2 will be there, 5 will be there. Getting it?
Yes, ma'am.
Okay,
Yes.
this is only A minus B. If B minus A we have to shade, then we will be having like this, like this. This is B minus A. Do you understand these things, Manvi?
Yes, ma'am.
Okay. So just a moment, few extra things are there, which is there in your syllabus. Let me take it. Can you see the screen?
Yes, ma'am.
So yeah, let's continue. Let's do a few questions from here. Yes, Nabila, these things has been omitted from your syllabus. So this type of question will not come in your exam. But yeah, till the Venn diagram, okay, and just the basics concepts. If you will just see the question, it will make sense to you. Yes, the formula you don't need to know. It will be there. All of a sudden you will encounter this type of thing in future, and there we will say that it was there in set chapter, but okay, all of a sudden it has been omitted from the set chapter. That means correlation is there, that here you are seeing the formula, then in class 12, okay, probability chapter is there, and there very often we use this formula. So if just for your extra knowledge, if you will know this formulas and everything, it will help you in class 12. Okay.
Okay, ma'am.
Uh, so let's see. Yes, Manvi, for you, basically, I'm explaining these things. So just a moment. I wanted to take word problem first. Let's see this particular question. Okay. U with the universal set. Okay. Number of element in A is 200. Number of element in B is 300. And number of element in A intersection B. So if I will draw this way, okay, in A, there are 200. In B, there are 300. Total element in A is 200. Total element in B is 300. And intersection, the common part, just the common part is 100, right? Right? Manvi, right?
Yes, ma'am.
Okay. And what we have to find? Then we have to find the number of element in A complement intersection B complement. Complement, you understand. Okay, what is complement? Here we have to find how many element will be there in universal set. Okay, universal set will contain how many elements. So let's do it. Actually, there is no proper exercise based questions over here. Yeah, I wanted to discuss actually these. Okay, this one. I will take that one if you want me to take, but this one. Out of 20 member in a family, there are 20 total member in a family are 20. 12 like tea and 15 like coffee. Okay, so tea, there are 12 people who like tea, and there are 15 people. Okay, total 15 people who like coffee. We don't know the common, how many common elements are there, we don't know. Okay, there are total 20 member. Now if you are thinking from this 20 member, how is that even possible that 12 like tea and 15 like coffee? How is that possible even? So let me tell you, here common interest persons are also there. That means we are doing survey. Nabila is there, Manvi is there, and I am here. Okay, So we are doing survey over here in between 3 people, and we are just asking who like tea, who like coffee. So maybe I can have coffee also. Sometime I can have coffee also, but more I like, okay, more I like tea. So that's, I'm saying I like tea. Now Manvi is saying she likes both. Okay, she like tea also and she like coffee also. So the, like, when we will count how many persons like tea, we will count, okay, my name and Manvi's name. And if I will ask Nabila that what you like, maybe she will say that I just like coffee, just coffee. Okay, so when we will count how many persons are there who like tea, so at least 2% we will count. And then we will count how many people are there who like coffee. Then again, 2 people are coming. Nabila is there and Manvi is there. And if you are thinking that we did the survey for 3 people only, and 2 like tea and 2 like coffee, how that is, how is, like, how exactly it is possible? So can you say it is possible? Same person is saying that I like tea also and coffee also.
Yes, ma'am.
Okay, that is what happening over here. That out of 20 people, you are having 12 who like tea, and there are 15 who like coffee. Okay, so this is due to this reason that so many persons are there who are saying both, both. Okay, so yeah, here there is a formula which Manvi, you know, that union intersection formula. That one of the formula is this also, and the basic formula is n a union b is equals to number of element in a plus number of element in b minus number of element in a intersection b. Okay, this is a formula. So we will use this formula. This 20 member means, okay, few like tea, few like coffee, few like both. This 20 means the union. Can we say this 20 means the union of both Manvi and Nabila?
Yes, ma'am.
Yes, Nabila, can we say that total 20 people are there? Okay, and union means either this or both. That means 20 is representing either this or that or both. We can say, right?
Yes, ma'am.
Okay, now number of element in tea, 12. Number of element coffee, 15. Intersection we have to find. That means, okay, common interest we have to find. Let me check. Assume that each one like at least one of the true drink. How many like both? Yeah, at first intersection we have to find. Okay, let's find the intersection quickly because I want to explain the next part also. So we will be getting number of element in a intersection b, that is 20 minus, okay, we can keep it over here, or you can do it like this also. 20 minus 12 minus 15, you will be getting 20, and 27 minus 7, that is negative of, okay, this is their number of element in a intersection b. So both will be, there are 7 people who like both. Getting it?
Yes.
Okay,
Yes.
7 people are there who like both. Now how many people are there only tea, who like only tea and not coffee? Only tea, only tea. Okay, this is such a tricky question in set chapter. Okay, if a person is saying, like, if it is given that 12 people like tea, if it is given that 12 people like tea, that means there are some people over here who like coffee also. Okay, so there are some people who like coffee also. If, for example, in real life, uh let me take a proper example. Okay, let me explain this question only. So if we are finding only tea, people who like only tea, that means from this 12 which is containing tea and coffee, okay, like so many people over here we are having who like tea as well as coffee. We have to subtract those people who like both. We have to subtract those number of people who like both. Okay, there are 7 people who like both. If we will subtract them from here, then we will end up getting the number who like just only T. Are you getting it?
Yes, ma'am.
Okay, so 12 minus 7 we have to do. Manvi, are you getting it? Why we are doing 12 minus 7?
Yes, ma'am.
Okay, so whenever only will be asked, that means both intersection. Okay, that means just the common you have to subtract. Think about it. If you are drawing a circle and you are saying 20 people are there, okay, and if I'm saying no, 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 I don't want to know everything, just remove the, okay, common part and everything. If there is any common part, just remove that portion, just omit it, delete it from here, and tell me what is there only in A, only in A, only this red colored shaded part. That means from 20 you will remove this part, the common one. Okay, clear?
Yes.
Yes.
This is also same question. In a group of 400 people who speak either Hindi or English or both. Either Hindi or English or both. That means this 400 is representing the union, because here people are saying either Hindi. You can see this either or both is representing that the data which is either Hindi or English or both. Recall that when in the class when I started explaining you the union, I said that union means either A or B or both. That's the union, right? That means union number of element in A union B, that is given over here as 400, right?
Yes.
Here it is given that 230 people speak Hindi only. Okay, we cannot say that number of people who like Hindi or who speak Hindi is just 230, because only means you can recall, only means this shaded part, this shaded part, this one, only this one is given to you as a 230. Okay, let's use the concept of Venn diagram. You know, here just 230 is given because only 7 speak both English and Hindi. 70, I mean 70 speak both. Then how many of them speak English only? See, from here only it is clear. Are you getting it? From the Venn diagram, you will be able to solve it. That total how many peoples are there? 400. Person who speak Hindi only is 230. Only 230. Common is 70. And then find how many speak English only. Getting it? From 400,
Yes.
if you will subtract this two added together, you will be getting only this one, right?
Yes, ma'am.
Without even using formula, we are able to do because of this only terminology. Previously, why we were using formula? Because we were using formula because properly it was given that these people like, okay, tea, these people like coffee. Only and all was not there. Then we will use formula. Actually, this formula came from there only. Okay, this formula came from there only. Suppose we are having a set A containing 1 2 3 4 5 6 7. Okay, we are having a set B containing, suppose 4 5 6 7 8 9 10. Okay, now A union B, you can understand. Okay, 1 2 3 4 5 6 7 8 9 10, that is A union B, right? A union B, number of element in A union B is all the number from 1 to 10, right? Right?
Yes.
Okay, that means total 10 elements are there. Number of element in A, 1, 2, 3, 4, 5, 6, 7. 7. Number of element in A is 7. Plus number of element in B, 1, 2, 3, 4, 5, 6, 7. Okay, 7. Number of element in B is 7. Are you feeling that while taking 7 plus 7, we have taken, okay, 14. So repeated element we have taken 2 times. Are you feeling it? That here 4, 5 we have counted. Okay, 6, 7 also we have counted. And here also we have counted them. Which, and in union we counted only one time. Yes or no?
Yes, sir.
That's why we have to subtract it once. That's why we say, let's subtract the common element. One time, let's subtract it. And from there only the formula came that the common element are 4, let's subtract it. Got it?
Yes, sir.
Okay, so this formula all of sudden, from where it came? It came from here only. Manvi, are you getting it?
Yes, ma'am.
I was talking about this particular question. These all are same. You read it after the class and try doing it. These all are exactly same. You will be able to do it. Just the last question I have seen, which I wanted to discuss. This one. Okay, the combination of 3 circles. 2 circle you are already understanding. Here it says that in a survey of 60 people, it was found that 25 read newspaper H. There is newspaper H. 26 read newspaper T. There is newspaper T. 26 read newspaper I. There is newspaper I. Okay, number of element in H is 25. Okay, number of element in H is 25. If only will be given, then we would have written over here, but it just says H, so we are writing 25 separately. Number of element in T is 26, and 26 no, newspaper I, so number of element in I, that too is 26. 9 read both H and I. Okay, here 9 read both H and I. 11 read both H and T. Okay, H and, okay, I mean H and I, that is 9, and H and T, that is 11. It's given over here. There, here. Okay, and both, wait, 11 read both H and T, 8 read both T and I. T and I, 8 reads both T and I. And 3 read all the newspaper. Can you see? Manvi, all the data is available to you. You can find the properly the union of H union, T union, I, right?
Yes, ma'am.
Okay. This is what I was talking about. Now here you have to see the number of people who read at least one of the newspaper. At least one means minimum one. Okay, minimum one. It can be two, it can be three, everything. If you will be able to fill this Venn diagram properly, okay, like by using the formula. Can you tell me, Manvi, what was the formula of intersection? Like uh, number of element in H union, T union, I. What was the formula?
Like N intersection
No,
that.
and that
Oh no, it A N whole A intersection B, that formula.
yeah, like
Okay.
union of three sets.
Okay, okay.
Yeah. What was the formula?
So union of three sets, ma'am. I know for two sets.
Three sets, you have seen the formula, no? Number of element in A plus number of element in B plus number of element in C minus number of element intersection B minus B intersection C minus C intersection A, okay, plus number of element in A intersection B intersection C. Have you seen this formula?
No, I did the two sets like N and A only.
Okay, this is the formula for three elements. Like union of all three that you can get from here. You can see all the data is already given to you. Number of element in A, that is given. B, that is given. C, that is given. A intersection B, that too is given. B intersection C, that too is given. C intersection A, that too is given. And A intersection B intersection C, that too is given. Can you see that? Everything is given in the formula.
Yes, ma'am.
Okay, you just need to drop the value and you will be getting the union of all of them. That means we'll be getting the total number of people. Okay, wait, here union is also given. Is it so? In a survey, 60 people. Yeah, it is given that total number of people were 60. So basically we don't need to use this formula. Just a moment, no? Number of element. It was found that 25 read this, 26 read that. This one. Okay, so this question, this is a formula, but actually this question we need to solve by using the concept of Venn diagram. Okay, we will be using the concept of Venn diagram properly. So suppose you are saying that let's use. Suppose you are saying that you are having A over here, A. You are having B over here, you are having C over here. Only in H is A, only in B is T, and only in this I in is C. Making sense?
Yes, ma'am.
Okay, so can I say that A plus 11 plus 3 plus 9, that is 25? Because number of element is in H. H is 25. Can you see that? So H, just focus on H. In H, A is there, 11 is there, 3 is there, 9 is there. Are you getting it? Everyone, Nabila, you also.
Yes,
Yes,
ma'am.
ma'am.
Are you getting it? Just focus on this circle. If you will understand
Yes,
this,
ma'am.
then it will give you more clarity on this graphs. Just focus on this circle. Manvi, A is there, 11 is there, 3 is there, 9 is there. Can I say all added together will be 25? Because 25 people read H newspaper. Yes or no?
Yes, ma'am.
So from here, we are able to take out the A value. Getting it?
Yes, ma'am.
Okay. Similarly for B. For finding the b value, you can say b plus 8 plus 11 plus 3. That is 26. You can see how easily you are getting the b value from here. And c plus 8 plus 3 plus 9. That is 26 people reading I. And from here you are getting C. Now you have all the data. Okay, now you have each and every data. You just have to answer the question properly. So the number of people who read at least one newspaper, minimum one newspaper. Okay, that means it can be two, it can be three. So all, okay, we can see this all added together will give us in a survey of 60 people. Read both, this read this one, this both, and this read all three. Yeah, okay, we have to check that all of them added together, is it giving 60 or not? That will be at least, if all the people are participating in the survey. Suppose just now we have done the we have just discussed that like three people are there, some like few of them preferring tea, few of them preferring coffee, and there are few preferring both. Okay, now if I will ask what is the number of people who prefer at least one of the, okay, drink, at least one drink, minimum one drink, so we will take all three, right? Right.
Yes,
Yes,
ma'am.
ma'am.
Okay, so here you have to check. In question, it is not written that all 60 are preferring reading the newspaper. You have to check after finding the A value, B value, C value. You have to check over here. All of them added together is what? All of them added together is what? I mean, I am telling you to check that the element over here, the element over here, element over there, all of them added together is what? If it is just 40, that means these are the number of people who are preferring reading any one of them or two or three. Getting it?
Yes, ma'am.
Okay, so we are not sure about this 60, that this is the union or not, because it is not written in detail after the 60 that from the 60 there are some who is preferring this one, there are some who is preferring other one, or there are some who prefer both. It is not given in detail that 60 is the union. That's why we are finding what will be the union. That union you can also find by using the formula, or directly you can count all the circles numbers. Okay, let's do the next one. While counting the numbers, please be careful. There is a chance that you will end up counting the same number twice. That's why I am telling you to fill the data, that here you are having A, okay, here you are having B, here you are having C. So you will add A, B, C, then you will add the common one. That means 9 red H and I. That means 11 red H and T. Okay, 8 red T and I, 8, and 3 red all. This way you will add A plus B plus C plus 8 plus 3 plus 9 plus 11. Clear?
Yes.
Okay, the most, this set, the problem based on sets are really easy. But only one confusion arises over here, that we end up counting the same data again and again, and hence we are not able to match with the answer. Next number says that the number of people who read exactly one newspaper, exactly one, just one. So you will be just taking A plus B plus C. No common part, nothing, just A plus B plus C. Those are the number of people who are just preferring H or maybe T or maybe I. Got it?
Yes, ma'am.
Yes, ma'am.
Okay, so yeah. Yes, Manvi, I want you to practice these questions by yourself. Solve it one by one and tell me what are the, like what are the types of question where you are getting confused. okay, which is not that clear to you. I want to, yeah, start with sequence and series now. Or is there any preference? First tell me, is there any upcoming exam? Nabila and Manvi.
No, ma'am.
No.
Okay, so let me continue with sequence and series. So yes, Manvi, I'm starting from the basic, okay? Here, finally. So maybe you will feel that some parts, okay, you did that day, but yeah, will be just beginning, from the beginning I'm starting. Having over here. Today I'm telling you what is sequence and what is series. So arithmetic sequence you have seen. If I will write 2, 4, 6, 8, 10, this is a sequence, right? Right? Right, Nabila and
Mm,
Manvi? This is a
mm,
sequence, okay?
Yes,
And
ma'am.
we are calling it arithmetic sequence. We were also calling it arithmetic progression. Arithmetic progression. That means this sequence is progressing, and there is a particular name for this type of sequence called arithmetic sequence or arithmetic progression. Okay, there are so many different types of sequence which may not be arithmetic sequence, and those type of sequence also you have seen in class 10 in first chapter, like I mean the first exercise that check whether this sequence are in AP or not, and you were getting, okay, so many questions over there which were not in AP, right? Right.
Yes.
So sequence can be in AP or it cannot be in AP. Sequence can be of any type. It can be of any type. Here we will be discussing special type of sequence, basically that arithmetic sequence, arithmetic progression over here again, and we will also be discussing geometric progression over here. Now for this particular, like series means what? So in mathematics, sum of n terms of, okay, the like sum of first n terms of AP you were finding by using SN formula, right? Right.
Yes, ma'am.
Okay, same thing. If I will the first one is is in arithmetic sequence, okay, it's in arithmetic progression. If I will write it as a 2 plus 4 plus 6 plus 8 plus 10, okay, plus like this, just with the summation sign instead of comma, if I will write the summation sign, then we will start calling it a series. Okay, series. Now series doesn't mean the final answer SN for the summation of 5 terms, summation of 6 terms, summation of 7 terms. SN value may be 1346 or maybe 1026. This is not series. This is series, just the representation. This added with that, the and just the addition sign, like 2 added with 4, added with 6, added with 8, added with 10. This representation we call it series, not the final answer. The final answer we call it sum of series. Are you getting it?
Yes, ma'am.
Okay, so here again and again you will encounter sequence. You understand, sequence can be sequence of book, sequence of pen, sequence of numbers. Here we will see. Okay, what is series? So series means those sequence addition, just the representation with addition sign, just the representation, not the final answer. The final answer is not the series. The final answer is sum of the series. Final answer is called as sum of the series, and just this representation 2 plus 4 plus 6 plus 8 plus 10, this is called the series of the given sequence. Got it, Manvi and Nabila?
Yes.
Now here you will be having, you will see that if we will be having the nth term of the sequence, for all of sudden I'll give you, there is a sequence whose nth term is 2n. Okay, then find the first term, then find the second term, then find the third term, then find the fourth term, then find the fifth term. And very easily, just by putting n value as a 1, 2, 3, 4, you will be able to find the first term. If you will put the n value as a 1, you will be getting the first term 2. If you will put the n value as a 2, you will be getting the second term as a 4. If you will put the n value as a 3, you will be getting the third term as 6. If you will put the n value as a 4, you will be getting the fourth term. And this is not any other sequence. This is the same sequence which I had written on the screen initially. Can you see that?
Yes, ma'am.
Okay, so sometime nth term, just with the help of a representation, will be given to you. Okay, for AP, I can explain you. For AP, how you used to find the nth term. Nth term was a plus n minus 1 into d. Okay, actually this can come from here also. If you will put the a value from the previous sequence, you don't know these things, you are just trying to find the nth term, so you are putting your a value, you are putting your d value just from the above just sequence. I just started today's class, written 2, 4, 6, 8, 10, and I am telling Nabila and Manvi what will be the nth term. Okay, both started finding nth term and both told me that nth term will be 2n. Now I am telling them that this sometime this nth term, just this nth term will be given to you, and you will be finding the first term, second term, third term, fourth term. Got it?
Mm. Yes, ma'am.
Okay, so here so many sequences. Okay, nth term will be given and we will be finding the first term, second term, third term, fourth term. Now there are some special sequence also. Okay, very special sequence. One of them is Fibonacci sequence. This is such a special sequence. Okay, there will be a, it will just go in a certain pattern. The first two element, the first two term of this sequence will be always be 1. For Fibonacci sequence, first two term will always be 1, always. Then the next term you will be able to calculate. How? By adding this two, 1 plus 1, 2. Next term you will be able to calculate. How? 1 plus 2, 3. Then next term you will be able to calculate 2 plus 3, 5. Then next term you will be able to calculate 3 plus 5, 8. Okay, anywhere in this world, anyone will say Fibonacci sequence. Okay, person will understand. Okay, this is a special sequence where the first two elements are 1, and after that it just keep on adding the previous two digits to give us the next sequence, next term of the sequence. And that's how this sequence progress. This is a special sequence whose name is Fibonacci sequence. Got it?
Mm. Yes, ma'am.
Okay, we sometime we also define the, okay, if we have to write the nth term over here. In AP we are having a formula. In GP, we will be having a formula to calculate nth term. But every time we don't have formula. If the sequence is this type of random sequence, then we don't have any formula which will give us so perfectly nth term. That means we have to just identify the pattern. And if we have to create the nth term, let's play with it. Let's try creating the nth term. Okay, so we say that nth term, okay, just from the third term. Third term is the third term of this one is the second term plus first term. Yes or no?
Yes, ma'am.
Okay, fourth term is we have taken the third term plus we have taken the second term. Fifth term is we have taken the previous one, fourth one plus before one, third one. Sixth term of this sequence is we have taken the previous to sixth one, that is fifth term, plus previous to that one, that is fourth term. So what will be nth term? Let's create a formula for nth term. We will be, if nth term we have to write, then can I say just the previous to nth term? That means can I say it will be n minus 1th term? added with previous to n minus 1th term will be, can I say, see, if you are having a number 5, previous one is 5 minus 1, that is 4th. Previous one is, okay, this 4 minus 1, or you can say whatever you are having, that minus 1. Getting it? So this
Yes.
is 4th place. This is 3rd place. If here you are having n, then previous one will be n minus 1. And previous one will be whatever we are having, that minus 1. That means, can I say n minus 2? Can I say this means n minus 2, n minus 1, minus 1 will be n minus 2? Yes or no?
Yes, ma'am.
Okay. Are you getting it, Manvi?
Yes, ma'am.
From here only we are creating the formula. That nth term is just the sum of previous two terms. Previous to n was clear to us, that is n minus 1. But before that, we are getting confused. So we tried recalling that we just have to go previous to n minus 1. That means n minus 1 minus 1. That means n minus 2. Even though it doesn't look good to us, we have to accept it this way. So we'll be having a n minus 2. This is the nth term of this Fibonacci sequence, where the first two term is fixed 1 1. After that only you will be able to find with the help of this formula. Okay, so you can say that third term will be here 3 minus